continue to the implementation. There are 5 parts for our final project. First one, high-level dimensional modeling. This is used to create business metrics and star schema. The next one is detailed dimensional modeling. This is used to define each of the dimensions and facts table, which can help us to generate the SQL code. Then our group used ETL with a Visual Studio to show the architecture of our data warehouse. We also choose relational online analytical processing server to store and manage the data. The final one is BI dashboard. This part will show the BI analytics we can get based on our data warehouse and provide some insights for the business case. Then let's move to the next slide. Bus metrics is used to define the grain type, granularity, fact, and dimension tables for our business processes. For our final project, we choose order transaction as the main case for the data warehouse. Let's move to next slide. This is the star schema for the order transaction. For the sales process, we will create 3 dimension tables to support the fact table, including customer, date, and product details. Each row on the fact table shows product name, order date, how many the customer purchased, and their cost. 3 dimension tables will show customer personal information, order date, and product details like name and descriptions. The range of order date is from 2009 to 2013. The right side are tables we will use from 2 databases.
Based on the high-level dimensional modeling, we have the detailed dimensional modeling. This is an example from the sales fact table. We include facts like product key, order ID, customer key, date key, ship date key, insert audit key, update audit key, quantity, and sold amount in the sales fact table. Then we will build ETL with SQL based on the sales fact tables here. I will have my teammate Ryan to introduce about our ETL process.
Detailed dimensional modeling process, we're going to walk you through our ETL process. So we did this using what's known as the source to target map and the SQL Server Integration Services package to stage our data and to load it to the data warehouse from our stages. We also referred to our ETL documentation along the way. So we first staged the data from the source tables. In this example modeled here, the date's coming from the external source. So we designed a data flow that can get data from the external sources and put it into the stage date. From stage date, we load it into the dim date. But for other dimensions, we're not loading them into dimensions just yet. So we just save them as stages. So for loading our transaction fact table, we designed a data flow that loads the stage customers, stage products, and stage order transactions to the order transaction fact table. So this is a high-level source to target map. As you can see, we're pulling our employee timesheets, employee supervisors, and date dimensions from our external sources in the databases. We then load them into the staging process. So we create stage date, stage FudgeMart employees, and the FudgeMart employees timesheets. From here, we load them into the data warehouse. So next we'll go over ROLAP, which is Relational Online Analytical Processing. Business processes are fact tables in our ROLAP star schema. The dimensional models represent the design phase of this. So ROLAP essentially allows us to access the data in a relational database. It's capable of creating highly complex SQL queries to calculate information at the right granularity for our end users, and there's no pre-computation required. So to go into detail, we essentially created a SQL query where we switched to our data warehouse database. We then used our dimensional modeling Excel workbook to begin the script. As all SQL scripts, we use the drop table commands that were critical for iteratively rerunning our code after making any changes. Then we added tables to the FudgeMart schema to avoid conflicts with other tables within our project, and then we executed our script against the data warehouse database to create a database diagram. So to load from the stage into the data warehouse, we brought our star schema to life essentially. And we documented our findings along the way to help us plan out the actual ETL process that we described. So if you need to combine two columns into one, for example, to replace null with like a value, then this will need to happen in the ETL tool stage for homogeneity in our data. Since the dimensions essentially depend on the fact table, we start with those first. So we open a new query, execute the commands to switch to our data warehouse database, and we proceed.
And our final step of implementation is to build the front-end report and dashboards. We chose Power BI as our business intelligence tool since it is in the cloud and it is interactive. This is a sales dashboard for Fudge Corporation. We can see some key visuals from both FudgeMod and FudgeFlix here. We can see the custom geographic location and the FudgeMod sales pie chart by product group. And you can also filter these visuals by different vendors on the right. In the bottom, you can see the FudgeFlix plan bill by month and also the plan bar charts. On the right is the highest ranking movie genres. We think it will be most useful for the executives to look at to learn about the company's sales performance and make business decisions accordingly. Next, we will move on to the data warehouse maintenance part.
After set up a data warehouse, the next step is data warehouse maintenance. To maintaining a data warehouse requires a bit more work, including keeping the data well organized, updating the warehouse to fit constantly changing business requirements, and also reviewing all updates with your entire staff. How to maintain the data warehouse? First, we need to remove duplicate entrants, clean up redundant data, keep the web log clean, and regularly delete summarized data, and then transform data by combining multiple fields into one field, breaking down data field into separate fields. Also, keep users of data warehouse well-trained on how to create queries, access database structures, and handle unexpected contingencies. Update statistic fields after loading new data to rebuild an index is also important. The people who maintain the data warehouse are business administrator and business analyst. Our business data management group and the data governance team consist of a cross-functional team of representatives from the business and IT field, with a shared version to promote data maintenance. Okay, I will let Ryan to talk about the audit.
Okay, next we're going to walk through the auditing process for our data warehouse. So auditing a data warehouse means essentially that we're assessing the efficacy of the control system and evaluating or mitigating the risks associated with the data warehouse. So we think there's three main reasons for an audit. First of all, most of the strategic decisions are based on the information that the data warehouse delivers. So there's obviously a high expense to this information, the quality of it being bad, and there's a lot of implications on the strategic decisions that has. Secondly, the cost is usually very high for developing a data warehouse. It's usually higher than $2 million. Third, data warehouses are very high-risk systems, and they have a contrasted failure rate of about 50%. So management must promote a system of internal control guaranteeing the protection of their asset. So for our teams and process, we thought it was threefold. I was tasked with carrying out the planning and organization aspect of it. Irene would be on data warehouse operation, and G would be on business integration. For this task, we thought that a database administrator, business analyst, a data architect, and a database analyst would be necessary. We would determine the minimum quality requirements for functionality and the data supplied to our data warehouse, and the result of the auditing process will serve as sort of a risk assessment associated. So data warehouse operation. Through interviews, we would determine if the new product development or modifications that are documented reflect that the internal and external interfaces are affected and how. Then we would review the existing test plans and obtain guidance for user acceptance test plans. The software would be tested according to the project test plan that we've established in the documentation, as well as the testing standards before being approved by the end user. The second deals with examining the underlying technological infrastructure. This has to do with system software security, updates, installation, maintenance, and monitoring of the database utilities. So we would determine what system security software is currently being used in the data warehouse environment, and we would determine if system software parameters that are selected in order to ensure the integrity of the data and the programs being stored. We would also probably review policies that exist for using and monitoring the use of these database utilities. Lastly, we talk about proactively taking action to manage changes. This is change request initiation control, emergency changes that pop up, changes in documentation and procedural changes, authorized maintenance, and we could determine these by questioning the methodology for prioritizing system changes requests from users. And then we would review the change control procedures in place to determine if a control log is used to ensure that all the shown changes are resolved. For planning, this would have to do with corporate policies, the segregation of duties. So we identify policies that clearly define responsibilities for corporate data warehouse owners and users. Information resources management and data processing personnel, such as senior management and database administrators, are also under question here. And like we keep stressing the importance of performing interviews, we would probably interview business units and IT personnel to ensure that not one individual is responsible for the data entry and verification, input of transactions for incompatible processing functions, or data entry and supervisory authorization functions. We would also review job descriptions to determine if they accurately reflect assigned duties and responsibilities, and we would review the physical and logical access controls that help restrict employee access based on organizational and individual job responsibilities. So this has to do with risk identification and a risk action plan, and we would determine if there is a current risk assessment approach that provides for regularly updated risk assessments at both the global and local system levels. And then we could talk about business integration. Here we'd be ensuring the system security. So for identity and access management, this means we're restricting access to data files, controlling access to the database, security profiles and passwords, and maintaining audit trails that allow us to effectively manage the data. So the data preparation procedures would have to be reviewed here. The data input authorization procedures, accuracy, completeness, authorization checks, error handling, and data integrity is also crucial here for processing, validation, and editing of our data. So that concludes our PowerPoint. Thank you for listening, and let us know if you have any questions. Thanks.